Okay, folks, we're going to get started. So, welcome to Ultralight Startups. This is the first ever Future Energy event here in Boston. Let's have a round of applause for that. So, my name is Chris DeLuca, and I run the Ultralight Startups event here in Boston. It's a regularly scheduled monthly event, roughly monthly, and we do it right here out of Microsoft Nerd. And the difference from this month to past events is that in the past, if you've attended, then you'll notice that the format is pretty similar, but the events are, the companies that present are all internet, e-commerce, online business style of events. So they're companies that are pitching web, mobile, social media companies and things of that nature. And this month, it's a different style of event, as you noticed, and it's all about energy. So we're focusing on an energy-themed startup, early-stage companies that are mostly local. Some have traveled from around, but mostly local in the area, and they're innovating and designing new style of energy generation. And so we're focusing on the earliest stages of these types of companies. Okay, so tonight we've got a different panel set up. So normally the VCs that are on the panel are also focused on internet companies, and we've got a few folks that are either in early stage angel companies or VCs as well from the energy business. So we're going to go through a couple of people. Before I get started and talk about the event, there's just a lot of people that have been instrumental in helping us pull this event together tonight. So a few people I want to thank. The first person is Willem Rensink of Shell. So he's been instrumental in pulling this together. So Shell has been our platinum sponsor, and so I'd just like to have a quick round of applause for Amy Goggins. I don't know if Amy's here, from MIT Enterprise Forum. Nope, okay. And we've got Ali Adler of Cleantech Open. Lorelei Farah and Jeff McCauley from Fraunhofer. Andrea Gulisano from the MIT Energy Club, or anyone from the MIT Energy Club. There's a few folks here. Good. Thanks. Chris Lulier and John Rohde from Mintz Levin Energy Arm. Jessica Van Sack of the Boston Herald, who kind of helped us preview and launch the Coming Out of Their Shells article. I don't know if most of you saw that. So Jessica, if she's here. Nope. All the presenters, of course, and Abby Fitchner and the Microsoft team who are co-hosting us here tonight. So, of course, there's one person that's standing up here that I didn't mention. That's Graham Lawler. So Graham Lawler runs the New York chapter, and he's also running Ultralight. He's also the founder of Ultralight Startups originally. So this creation is thanks to Graham. So a quick round of applause for Graham. And then some of our promotional partners, a lot of people that have been instrumental in getting a lot of you to attend and create the awareness of the event. Mass Innovation Nights, Massachusetts Clean Energy Center, the Massachusetts Tech Transfer Center, Boston Inno, Greentown Labs, and Work Bar Boston. So thank you all for the partner and the partnerships and helping us pull this event together. We're about to get started, and before we do, I just want to point out the room is pretty full. And so we've got an exit over here. We've got another exit over here, just in case you need to run out. All right. And so now we're going to introduce the panel. And so the first panelist here is David Miller. David's the managing director of Clean Energy Venture Group. Then we have, as mentioned, Willem Rensink of the GameChanger program at Shell International. Then Mark Goodman. He's the founder of Terawatt Ventures. And then Nikhil Garg. He's the VP of Black Corporate Capital. So now I'm going to just ask that the panel introduce themselves, and we'll start with David. If you could tell us your name, a little bit about Clean Energy Venture Group, and what's your most recent investment and why you're excited about it.
So, Dave Miller with Clean Energy Venture Group. So Clean Energy Venture Group, we're an angel group. We're not a fund. We invest in early stage clean energy, generally technology companies. As an angel group, we don't put a ton of capital into companies, mostly bring in our own background, expertise, networks. We have 11 partners in the group. We've invested in 16 early stage companies, which is close to our capacity at this point. Our most recent investment is Practically Green, and that's a company that uses, it's a personal sustainability platform on the web that is primarily could be used for anyone, so go to practicallygreen.com and check it out, but is especially being used for employee engagement in large corporations around sustainability.
And Willem Rensink of the GameChanger program.
So my name is Willem Rensink. I'm with Shell, based in Houston, and we're part of the GameChanger team. And what we do is look for radical innovation approaches, and they can be all over the energy space, so both traditional oil and gas and also alternative energies. That's why we're reaching out to this community, and we act as a angel investor for external technology collaborations, and very flexible in how we can work with people, help companies start it and create interesting opportunities for both Shell or the external partner. And so you can check us out at our website. It's shell.com/GameChanger, and that's where anyone can submit a great idea, and that's how we typically attract people.
Hi, I'm Mark Goodman. I founded Terawatt Ventures about 3 years ago. We invest broadly across various energy sectors, but narrowly in really sharp teams who've come up with very creative ideas or breakthrough technology. My most recent investment is in a West Coast company called Next Step, not to be confused with Next Step Living here in the East Coast. Next Step, STEPPE, is a feedstock solution company for the biorenewable industry. I'm excited about the investment for a lot of reasons. First and foremost, the CEO is one of the most, I think, competent, dynamic, exciting people I've met, and she has shown herself in the early stages of this company to really know how to build a company. And she came with the right experience, and she's building the company in the way that I and my fellow co-investors thought she would. She's also figured out a way to capture the upside in a vast space with a lot of technology risk by focusing on an aspect of the value chain that everybody needs. And this is the feedstock for all the various biorenewable conversion technologies. So if you think about it, it's sort of upstream leverage. It's a way of not having to bet on one technology winner, be able to bet on a broad space and get leverage that way. So very excited about that one. All my companies, but that's the recent one.
Thank you, Mark.
Hi, Nikhil Garg with Black Coral Capital. Black Coral, we're a family office that invests in clean technology companies and projects, multi-stage investors from early stage venture capital, growth equity, and then project finance as well. In terms of our most recent new investment, a company called Cilantro based out of Ottawa. They are doing work around power conversion technologies for the PV sector, and very excited about them because they're based on their technology roadmap, looking to deliver all the advanced capabilities that we've seen out of the microinverter market, but at a significantly lower, significantly lower compelling cost basis, and also led by a world-class management team with a very successful track record out of the semiconductor industry. Yep. Also excited about all our other companies like Mark too.
Thank you, guys. So now I'm going to hand it over to Graham, and Graham's going to tell us a little bit about how the event is going to run tonight from a format perspective, and also how the pitch timing will work in regards to the Twitter voting and the prizes associated with that. So now's a great time to get out your mobile phones and iPads and computers. Someone asked me for the Wi-Fi password. So if you're looking to connect to the internet here, Wi-Fi ID is Cambridge, and then the password is ST0514. That should get you on. Okay, Graham, take it.
Awesome, thanks, Chris. So here's the format. We're going to see 8 pitches tonight from energy and clean tech technology companies. Each one is going to have a particular format, which I'll get into in a second. You all are going to decide which one of those wins prizes by voting for your favorite startup over Twitter. And as an added twist, you're also going to vote for your favorite panelist over Twitter, who's going to win the illustrious award of Panelist Choice, Audience Choice Award. After the contest and the prizes are awarded, we're going to go over to Mead Hall, and we're going to have some drinks. So talked about the panel. Here's the format of the pitches. Each company is going to get 3 minutes on their own to stand somewhere over there. We're going to show 2 PowerPoint slides that they have prepared for us, and you're going to listen to their pitch about their company and their technology. Then we're going to have 3 minutes of Q&A. Primarily, that's with the panel, so the panel is going to be asking a lot of questions. If you have a question, definitely feel free to raise your hand, and if we can squeeze you in, we will definitely call on you. And then we're going to have 3 minutes of advice from the panel. So this is, if you know, from the panel's perspective, if I was that entrepreneur, I had this company, I had this technology, what should I go home and do tomorrow? So that's really what you're going to be judging the panel on. To vote, you send a tweet, a single Twitter message with #Future Energy and the startup's Twitter handle to vote for that startup, or #Future Energy and the panelist's Twitter handle to vote for that panelist. You can actually vote for multiple panelists and multiple startups on the same tweet if you want to. Just make sure you have the hashtag #Future Energy. Do you want to talk about the prizes?
I'm sorry, this says pound ultimately.
It does. How about that? Go for #Future Energy. That's what we're counting. So, Future Energy.
So why don't I tell them a little bit about what they could win? So everyone tonight will be competing, as Graham mentioned, with the Twitter competition for these great prizes. So the first prize we have here is the Cleantech Open Northeast application. So as mentioned, Ali Adler's here, and if you'd like to learn more about Cleantech Open Northeast, please contact her. Ali, if you'd just like to raise your hand again. So it's an accelerator program, and there's a application process. The application just closed. The deadline just closed it was May 8th, if I'm not mistaken. And so you'll definitely be fast-tracked for an application for the next program, which is, I guess, next year, right, Ali? So that's a great prize. And then AWS credits. So Amazon Web Services, a lot of startups and entrepreneurs are using Amazon Web Services for hosting. So this is a great $500 credit towards your all Amazon Web Hosting services. Each of the top three winners will actually win each $500 worth of services there. Mintz Levin Legal Services. So the top winner will win $1,000 worth of legal credit from Mintz Levin. And then a week pass to Work Bar Boston. So Work Bar is a co-working space just down the street over by South Station, and it's a co-working area. And all pitches will receive a 1-week pass to this space as well. And as Graham mentioned, you'll be voting for your favorite panel, who will win that illustrious prize of the Audience Choice Award.
Awesome. I think that's it. So should we get started?
Let's get started. Okay. So the first pitch of the evening. Ben Polito from Pika Energy. So, Ben, are you here? Great. All right, so let's get pen up. And if you can stand somewhere right in the middle here, so we get a good view of you. We're going to drive the slides.
Very good.
Okay, so as Graham mentioned, it's 3 minutes of pitch, 3 minutes of Q&A, and 3 minutes of feedback. The only time that you can give a response from the panel is during the question and answer session. The final point of feedback is just a takeaway. Okay. So you've got 3 minutes.
Hi everyone, I'm Ben Polito, co-founder of Pika Energy. We make small wind turbines that help families cut their electric bills and reduce their environmental impact. 15 million US homes have enough wind and enough space to put up a turbine. But adoption at this point is less than 0.1%. And that's because the turbines that are available today can't compete with dirty power from the grid. We have the perfect team to tackle this challenge. That's because a few years ago, my co-founders and I helped design the #1 home wind turbine in the world today for a company in Arizona. That turbine's called Skystream, and it was a huge step forward. But with an installed cost of about $20,000, it's far too expensive for most families to afford. So we're developing a turbine that costs about $7,000 and pays back 40% faster. So how do we do this? Basically, 3 areas. First, the blades. We've invented a way to mass-produce lightweight, high-performance wind turbine blades using a cost-effective injection molding process. Second is the generator. We've designed an alternator that's highly efficient, cost-effective, and extremely quiet. And that's critical because customers just won't tolerate a noisy wind turbine. But the most revolutionary thing about our system is the plug-and-play electronics that connects it to the grid. This system, indicated in red on the diagram here, has several customer benefits. First of all, site flexibility. Our system enables 2.5 times longer wire runs with lower energy loss. And that means our customers can put their turbines on the windiest part of their site and capture more energy. Second is hybrid systems. Wind turbine customers tell us that they want to be able to add solar to diversify their energy mix. So our system is built from the ground up to enable wind-solar hybrids so customers can take advantage of low-cost solar. Third is our exclusive built-in Wi-Fi connection, so customers can track their system performance from anywhere in the world and share with friends online. And finally, forward compatibility. Our turbine is compatible with emerging standards for DC energy distribution. And that means soon you'll be able to charge your electric vehicle directly from wind and solar power that you produce at home. All of these innovations are in service of our core goals: lower cost, faster payback, and a better user experience. We founded the company about 2 years ago, and in 2010 we flew our first generation prototype. In 2011 we built and tested our second generation product prototype, and we've already demonstrated significantly higher efficiency than anything you can buy today. We filed 4 patents, and we're going into alpha testing this summer, working with the largest installer of small wind turbines in Southern California.
15 seconds.
So at this point, we're looking for private investors to get involved and help us accelerate commercialization. Thanks very much.
Right on time. That's how it's done. All right. So let's move into the question section. So Nikhil, we can start with you. What questions would you like to probe at to understand a little bit more of the company?
Yeah, sure. Good starting point would be to further understand the economics. You mentioned that you cut electric bills. Can you comment more on by how much, what sort of paybacks are associated with it? What does the prevailing rate of utility power have to be for the economics to work out?
Right. So it's highly dependent on the wind resource, obviously. Our system is designed to produce somewhere, the wind turbine aspect of our system produces about 1/4 of the household's electricity need, and then you add the solar, and then you're up well over half. The system cost of $7,000, typically the paybacks will range from, in California, you can get paybacks between 3 and 6 years, and it ranges widely from there in state to state.
And Mark?
Ben, I found myself thinking during the pitch that this might be the perfect technology for residential wind, but there's not a big market for residential wind. I mean, I think the uptake of 0.1%, while there's obviously a lot of opportunity there, I think it is suggestive of the market appetite for residential wind. And I don't know why solar is so much more popular, but I think it's pretty clear that it is. There's probably some siting issues, the amount of power relative to household needs. You just mentioned 25%, but obviously you get a lot of you get regulations and sort of tax issues driving some of the adoption, some of the payback period. So what convinces you? I mean, you guys are your team is clearly the team to do this. It looks like you've got the right technology, but is this a technology looking for a reason to be? What evidence do you have that there's a real market here to sell this?
Well, we've talked to both a lot of installers and a lot of people who actually bought these wind turbines, and our takeaway message is that cost really is the issue, and that attractive payback would really turn the thing around. So that's basically the starting point. Is that if the systems that are available today just aren't, you can't write a payback on them, and so for instance, you can't get into the solar leasing, and that's what's exploded the solar market in large part in the last few years. So if we can get to where the economics will support that, then I don't think we'll have any trouble. It won't go to the market penetration that solar will, just because of the nature of the resource, but it can go much, much larger than it is now.
We've got time for just one more question. Go ahead, Willem.
So from a regulatory point of view, what limits the deployment of windmills at residential properties?
So basically, it goes by the local jurisdiction. It's about the codes in that town, and so that's an obstacle. But the good news is that it's definitely moving in our direction. The Distributed Wind Energy Association has been doing great work with model ordinances and expanding the opportunities. So we haven't had much trouble in southern Maine at all, and I think that's indicative of a lot of places.
Okay, and I think that concludes the questions just based on time. So sorry for that. So what we'll do is, David, we'll start with you in terms of feedback. I don't know if you got the answers to your questions in mind, but hopefully you can give Ben a takeaway message.
Actionable advice. What would you do if you were him?
Sure. Okay, well, I'm going to start, and I'll change my questions to statements, I suppose. So one thing I had a question about was the manufacturing cost and process. And so as an angel investor, I would be very concerned about, what is going to be the cost to scale this business? What is the cost to manufacture these turbines, and how do you scale up that process, and what is it going to cost to scale it up? And then obviously attached to that is, what is your sales and distribution strategy, which also could be costly, because you have to, you want to sell a lot of these, right? And you want these to be in every home. So how do you have a national distribution strategy, and also how do you manage the cost and scaling of that? Other questions I had were about the site requirements, how much of the country, how many homes are applicable for this. You addressed that to some degree, but I want to know more. And also IP issues. Coming from another company that did something very similar, I want to know that there's a clean IP history there, and the patent protection for your new technology. And I'm assuming that you have the right answers to that. So I'd really be focused on your manufacturing, scaling and cost, and distribution, scaling and cost.
Great message. Willem, feedback message?
Yeah, so I think the strongest selling point I recognize is the total integration that you have with solar. And you mentioned that typically you see more penetration of solar. If you can piggyback on that a little bit and find that integration as a sort of target first people that want to be off the grid, and see whether you can break in there. So I think strong partnerships, where you can distribute, and also maybe you can tip in. You mentioned the solar leasing. Well, maybe you can expand that to wind and really get a strong financing partner on board as well.
And Mark?
I also thought there's interesting opportunity there about the integration aspect of it. It's kind of a Ethernet for energy. And is this differentiated enough and defensible enough to be the Ethernet for energy? Could you sell that Rebus platform as a network?
And Nikhil?
Yeah, my comment would be on having that really crisp go-to-market strategy in terms of who you're going to be targeting, what that message is, that sales message is to them, whether it's that cost and value proposition, if it's that zero down first cost with a lease financing mechanism, if it's a more reliable system, the aesthetics are better, all these considerations that customers think about, and really understand where you fit in from a customer needs spectrum, identify that subsegment that you super serve, and really focus on them up front.
Great takeaway.
Thank you.
Awesome. Thank you, Nikhil. Thanks, Ben.
Thank you, guys. Congratulations. All right, so
You want to tell them how to vote? So if you want to vote, send a Twitter message with #FutureEnergy and what's the Twitter handle?
it's at Pika Energy.
Pika Energy. Okay, and don't forget to vote for your panelists, for whoever you thought gave insightful comments and feedback there.
Great.
All right. Go ahead.
So why don't I introduce the next one up? So it's Roger Faulkner from Ballistic Breaker Corporation. So Roger's here to tell us about Ballistic Breaker, and here's your mic. Okay. We'll pull up your slides.
He's got the laser pointer.
You get your laser pointer. There you go. You've got 3 minutes.
All right. Ballistic breaker is a circuit breaker that can work equally well for DC or AC power. Most circuit breakers, all mechanical circuit breakers that are available today, involve the separation of electrodes, which ignites a powerful arc. The arc damages the device, and that limits the life expectancy of the breaker. So what I have that's different is that the power goes through this breaker, and when it rotates, there's a contactor here that sends the power through an increasing series of resistors. So that results in a soft circuit opening. It means that the switching transients are minimized. Switching transients cause all kinds of grief. For example, they can crash a computer, or they can fry a transformer, and both those things actually do happen. I mean, most of you have probably had a computer that got fried by a switching transient at one time or another. So this technology is fast compared to the incumbent DC breaker. Probably the most important thing is that it works equally well for AC and DC power. It's the only breaker I know of, except for electronic breakers, that work equally well for AC and DC power. And compared to the electronic options, power electronic breakers are much more expensive, and they have fairly high on-state losses. So you have to get rid of that waste heat. That means generally that at the megawatt level you require liquid cooling, and liquid cooling is quite a problem for a circuit breaker. It's based on components that, although they're not off-the-shelf components, but they're all readily manufactured components. Next slide. So what the crux of this technology is that it will expand the applicability of DC power transmission, which has all kinds of applications in renewable energy. For example, wind farms and solar farms, both benefit from it. Anytime you have multiple power inputs to a grid, like for example in a wind farm, the wind turbines want to be going at different speed. So if you have a DC grid, you don't have to synchronize it. The same thing's true in a factory. If you have multiple manufacturing processes that have variable speed motors, it's less expensive to have those drives run on DC rather than the way it is now, which is at each motor you convert to DC and then you convert back to AC again with a variable frequency drive. So onboard ships is a really big application. The Navy is hot for a 6 kV breaker. So essentially the most important thing is that this is a scalable idea. It can work all the way from vehicle systems to high voltage breakers.
That's great. That's time.
Okay.
So Q&A. Whoever's got a question first, jump in.
I can start. So is the breaker fast enough to be safe for all these applications?
It can operate in less than a millisecond. So I think, according to my calculations, pushing it to the absolute mechanical limit, it could go to 200 microseconds. So one of the innovative aspects of my IP is a very fast release. It uses piezoelectric crystals that basically let the brakes off much faster than any other mechanism that I've come across.
So 2 questions, if I may, since now I get responses this time. So one is, on the technical side, is there any effect on the efficiency of transmission through these systems? And on the business side, you talk about all these potential applications, but who's your initial market? Who are you selling to? What's your business model?
Yeah, actually I have a customer number 1. It's Comprehensive Power in Marlborough, Maine. They've signed up to co-develop it with me. They're on a grant application for the Mass CEC, and they've agreed to do the testing, and they've given me a purchase order if I can produce the thing according to their specs. And there are several others that the market pull is from people that have big DC motors, basically, because they have a very pressing problem. There are many other applications like data centers and the Navy application that are a little further up, but people that want to control variable speed DC motors are the first application area. What else? You asked me something else too. Oh, the efficiency. Heat generation is directly proportional to that. So these things don't produce enough waste heat that you need to cool them. So that means they're very high efficiency.
Another question from Mark or Nikhil?
Roger, what kind of company do you want to build? How do you bring this product to market, and who buys it?
Partnerships are really critical in this. So for example, Rolls-Royce is interested in the aircraft application. DRS Power is interested in selling to the military. There's another company that I just met with that's interested in the offshore wind market. So the way there are many companies involved in circuit breakers, and I think the right way forward is to form partnerships that address particular market niches with different companies that are already selling in those areas.
So how much product development or adaptation do you need to do for each of these market segments?
I really believe that once the basic principles are determined, that we'll have the design criteria to just design and build breakers for any power, any voltage. It comes down to some things we have to find out about. There's a critical condition. Whenever the conductive part is moving away, you've got to make sure that you don't have a plasma arc follow it. Once we determine those conditions, I think they can be applied, and you'll be able to plug in the numbers and make a breaker for any application, at least close, and then you have to probably refine it. I don't think it'll be very expensive, really.
So I got another question that's maybe pretty naive, but so you mentioned you talked to Rolls-Royce about an aviation application, but they got a current application, I assume, in the breaker technology.
Yeah.
So what is it that either you think you can displace that current solution, or why they think you can, or what advantage do they recognize?
It's lower weight, for one thing. Also, the fact that you don't generate arcs means you're not damaging, so you get longer life. And another thing is switching transients. Anytime you have electronics on the circuit and you're generating switching transients, you're reducing the life of the electronics or possibly frying it.
Okay, that's time.
Great. So let's move into the feedback session now. Nikhil, why don't we start with you? Piece of advice, takeaway message. What should Roger go home and do tonight?
Sure. I would really build on Willem's comments and looking at the different opportunities you have, lay out what is that value proposition for those end markets. Is it a cost savings? Is it increased functionality? Something else? And really identify where that first big opportunity for you is, and focus the business around that in the near term.
Mark?
Roger, I've seen you present a couple of times now, and first, I respect your persistence because I know you've been at it, and I hear the evolution of your pitch, and I commend you for, number one, getting this first potential partner customer, because what I've always felt in your previous pitches was, here's a guy who really knows what he's talking about from a technology point of view, but not always focused on the commercialization process. I hear you starting to do that, and I think it's great, and I hope you continue to look for those partnerships.
Willem?
Yeah, so again, it's similar to that. I think as I recognize you know what you're talking about, but still have a hard time explaining to me why this is better. And I can see in the DC networks, that's where you say, okay, that's emerging, so new technology is required for, to get that market established. But then for existing or replacement, it's difficult to see how you can replace something that, most applications pretty much work and as they are. So I think defining both where you can grow with the rollout of new technology and break into new markets and sell that benefit, I think is key.
And David?
So I'm going to try and pull together, I think, a theme across a lot of the questions and advice here. And that is, you talk about a lot of different applications and markets and potential customers. And I think as a startup, you really want to focus like a laser on, where's the customer that has the greatest pain? What customer, maybe there's an area, maybe there's a technology this is particularly applicable, but where is there a customer who wants to spend money, who has the greatest possible pain that your solution is going to meet, and then what is the value proposition for them, get them a system, and then, get feedback from them on how you're going to meet that pain, and then expand it from that, have a beachhead.
Great advice. So how about a round of applause for Roger, Ballistic Breaker? I'll take that from you. Okay,
All right,
next.
thanks very much, Roger. So if you want to vote for Ballistic Breaker Corporation, you will send a tweet with #Future Energy and @Ballistic Break, which can be found in your handout as well. And don't forget to vote for your panelists, for whoever you thought gave the most insightful advice.
Okay, so thank you, Graham. So the next pitch up is Neil Livingston from Carbonaceous. Neil, are you here? Didn't see you before. Okay, maybe he's running late. So why don't we go to the next one? So Deckard, Sorensen, NBD Nanotechnologies. Is your microphone? Why don't you take the microphone with you?
Yeah, you have to use a microphone.
Yeah, you do.
Yeah, we're recording this on video, and if you're not speaking into the mic, we won't get that. And be sure and speak directly into it. And ideally, you got to stand right in the center there too. Sorry.
Okay, you've got 3 minutes.
Hello, my name is Deckard Sorensen, and I represent the NAMI Beetle Design, now known as NBD Nanotechnologies. We are a company that uses biomimicry and nanotechnology to solve today's world's water crisis. How we do that is biomimicry is the creation of sustainable technology through the inspiration of nature. Our inspiration comes from the Namib desert beetle. This beetle has the ability to survive in the Namib desert by crawling up to the top of a dune, sticking its back to the wind, and collect a life-giving drink every morning. The first part of our design is to mimic this and create a material that has the same ridges on the back of this beetle. These are super hydrophobic and super hydrophilic ridges, or water-hating and water-loving ridges. These are on the nanoscale that have the ability to collect up to 4 to 40 microns of water, which is about 10 times smaller than the size of one droplet. The second part of this design is the temperature gradient. First, I would like to mention this is a picture of a material that we've already made. This is the super hydrophobic portion, where the droplets appear as tennis balls and actually did not want to go on it so bad that it bounced up and down. We have then placed the super hydrophilic ridges onto this material on a nano level. We intend to collect this water through a steep temperature gradient. This is a picture right here of an airplane that was coming back from the Dominican Republic. 80 degrees on the outside, nice and AC on the inside. Condensation was forming on top of the plane. What we do is plan to combine both of these aspects into our flagship product, that is our patented design, as seen right here. We use a DTC, which is a differential temperature control that funnels air into a small cylindrical portion that uses small nichrome coils to heat this air coming in. Now, hot air is buoyant, so therefore it will travel upwards, and as it expands, it will naturally cool. This is seen in our three-dimensional thermofluid simulations right here. The difference in temperature can be created from this ambient temperature change. We release the air through the top and fins. Now, the second part, obviously, is applying the nanomaterial to this temperature change. The second largest reservoir of water in the world is the air. We will use this air, create this temperature gradient as seen right here, and place our nanomaterial on the inside layer. This nanomaterial will collect the condensation from the air and collect it in a water pool right here. The water pool will allow for the water, once it reaches a certain capacity, to fall down underneath into a collection area. We hope to collect up to 1/2 liter of water per hour. We are NBD Nanotechnologies, and we plan on making a big deal in the water sustainability. Thank you.
Okay.
So we're going to move into our question and answer round here. So anyone can jump in so that everyone gets a chance. So who would like to start with a question?
All right, so just how much will it cost to produce a liter of water, and who are you going to sell it to, and how are you going to sell it?
Okay. First, our product we expect to cost between $50 to $200, depending on the size of our order, our first manufacturing. We're still on our prototype stage, however, and once we have created, once you buy our product, you'll be able to sustainably run this for 24 hours via a solar panel running our machine.
So what's the operating cost, and how does it? And do you know how much it would cost to actually produce?
We expect it to be able to be run. We're not sure On operation costs, it shouldn't be that much because it is run from the solar panel that is built into the top of this, and that will run the temperature gradient, or the coils that produce the temperature gradient on the inside of this cylindrical portion right there.
And who are you going to sell it to, and how are you going to sell it to?
Originally, our inspiration was to put this in a greenhouse, because you could put a greenhouse virtually anywhere and start a organic produce revolution. However, it is much more pertinent today to sell it to big companies that are much invested in clean water revolution. Places such as Africa, the Middle East plans on investing $1 trillion by 2020 in renewable water resources, and we plan on pursuing, there's a multitude of markets, but we plan on starting with bigger businesses first.
Another question?
Yeah, Deckard, could you talk about where you are in your R&D process, and what are the major technical and commercial milestones you see out ahead?
Yes, we this is our patented design. We are looking for a prototyper currently so that we can begin creating this, and we have already successfully created a sample of the nanomaterial, and you can see that on our website, nbdwater.com. And we plan on putting that on the inside of a prototype upcoming this summer.
So you do mention that the air holds a lot of moisture, but what's sort of your cutoff concentration you need, because it's not always as much moisture in the air as everywhere?
Generally, as the humidity in the air goes down, you need a steeper temperature gradient. However, at room conditions, there's about 0.02 humidity in the air, and it goes up to 0.0002 for a 30-degree temperature difference. However, without any humidity in the air, we plan on pivoting and using a bubble that will produce humidity in the air, and then we'll collect the water sustainably through our solution.
And that's time.
Good. All right, so that's perfect. So now we're going to move into the feedback session. So we could actually start with Mark, if you'd like.
Yeah, so I missed how much water you could generate in theory in 24 hours.
We plan on generating about 6 liters every 12 hours, so about 12 for a 24-hour period.
All right. Have you talked to the military? Or should I, in the phrase of a comment, please talk to the military?
You should talk to the military.
I mean, 'cause, you know, this is obviously something that...
We haven't, but it's been proposed to us.
Deckard, you're just listening at this point.
Oh, sorry.
Yeah, I mean, they buy this stuff, and I don't know what you want to do as a company, but it's an interesting route.
Willem?
Yeah, so I wonder who needs 12 liters of water per device per day. But I think if you can scale that and you can really hit mass production, there might be domestic applications for people that just want water for their yard or something like that when it doesn't rain. But I'm still thinking you need to do something about the scale. And you mentioned the $50 to $200 with the solar panel and some heat convection, some nanomaterials. I think that's going to be pretty tough. So I think getting an early handle on the manufacturing process and what it is you really need, and how much the nanomaterial is going to cost, I think it's going to be key to see what application you can really target at that rate.
Takeaway message, David?
So this is a neat idea. Congratulations for getting this far. So now the question is, how do you turn this into a business, right? And I think there's some analysis that has to be done. I think you really want to get a strong handle on how your customers are going to see this. What is going to be the operating cost? How much is it going to cost to produce the water? How are you going to produce enough water to meet their particular needs? Take one step at a time. I mean, I think it would be helpful to have further demonstration of the technology. I mean, that's going to go a long way. But in parallel to that, I think you really want to do the analysis of the cost, and think of yourself as the customer. How are they going to be buying this system? What are they going to be thinking about? And what are they going to want to spend, and how are you going to meet their needs?
And Nikhil?
I would second David's comments, but over and above, I'd say that as you hit some of your upcoming demonstration milestones around the technical efficacy, that you should begin to look for conversations with strategic partners. There's a lot of moving pieces here, from the technology development to the distribution model, the materials that you're working with. There's a lot of leverage that you could get from the right strategic partner. So you mentioned the water companies that are active in this space. You should think about beginning those conversations sooner than later.
Great job. Congratulations. Good job, Deckard.
Thanks very much, Deckard. And if you want to vote for NBD Nanotechnologies, send a tweet with #FutureEnergy and @NBDWater. Also, don't forget to vote for your panelists for their insightful comments and insights and helpful advice. So we'll do one more before the break.
That's right. So we're going to do one more pitch. Won't take a break. We can stretch your legs. So the next one up is Yuriy Tolmachev. And Yuriy's here pitching Ftorion. Hand you your microphone, Yuriy.
Just stand right between the two screens and speak directly into the mic if you can.
Can you hear me?
Got 3 minutes.
So my name is Yuriy Tolmachev, a founder of Ftorion Incorporated. I'm a professional electrochemist. I've been working on fuel cells and batteries for the last 20 years. And I came to the conclusion that neither of these technologies can enable fully electric vehicles. This slide shows problems that common to different type of batteries. Basically, it's low power density, low energy density. That means small driving range, and also long recharge time. I have numbers for Tesla Roadster here. You can see it. Problems with fuel cells are of different nature. It's mostly cost, efficiency, and durability. Intrinsically, fuel cells are better suited for transportation applications because they have higher energy density, longer driving range, and allow for independent scaling of energy and power. Polymer electrolyte fuel cells in particular were considered as the most promising technology for automotive applications. Unfortunately, I can tell you now, it's not going to make it on the roads. And the problems there come from only one component, the oxygen electrode. Normally, we think that oxygen comes from air, and air is free. So for the longest time, fuel cell developers were reluctant to consider the idea of abandoning air as the oxidant and carrying an onboard oxidant. I decided to get rid of this hang-up and came up with an idea of rechargeable gas battery. So here's a schematic diagram of it. It still uses hydrogen as a fuel, but instead of taking oxygen from air, I carry it on board. So this technology allows for two charging options. It can be charged electrically, like a regular electric car battery. It also can be charged mechanically, like a gasoline-powered car. The only difference is, instead of pumping one fuel, you pump both fuel and the oxygen at the same time. And when you go to the charging station, you drain spent fuel and pump fresh charged fuel and oxygen. The spent fuel is regenerated on-site by electrolysis within a few hours back to fuel and oxygen for the next customer. So this approach does not require development of hydrogen infrastructure, which is considered as one of the major obstacles to adoption of hydrogen economy. Also, it doesn't generate any waste. Everything is recycled. At this point, I have identified two chemistries for the oxidant. One is a gas, and the other one is a melt at 250 Fahrenheit. First slide, please. So here at the bottom, you see
15 seconds.
Parameters for this technology. What I want to say that this technology is not a winner at any parameter. Fuel cells beat it energy density, batteries beat it power density, but it presents a compromise that actually enables a device that's perfectly suited for automotive applications.
And that's time.
Great job. Round of applause. Okay, so now we're going to move into the question answer part. So whoever has a question can jump in first.
So
Willem?
to me, it looks like that you still need hydrogen that comes from the electrolysis of water. Is that correct?
No. That's the point. It does not need hydrogen infrastructure. Hydrogen is generated by electrolysis of the spent fuel.
But you do that, you mean in the car? But the spent fuel is
It
water.
can be done in the car overnight or during parking, or it can be done locally at gas station. There's no need for hydrogen infrastructure.
No, but the spent fuel is water.
No, it's not. Because the oxidant is not oxygen.
Okay.
Other questions?
Okay, well, we have a really good idea of who the customer is, and we'll put aside for a question of how do you sell to them. Are there safety concerns, temperature range at which this operates at? What happens when you have a vehicle accident? It's a major issue, of course, with alternative fuels in cars.
The best answer I have is actually belongs to a Caltech professor who was asked about dangers of hydrogen economy. And he said, if internal combustion engine was invented today, the Highway Safety Administration would never allow it on the roads.
Does that answer your question?
So we're presuming then that this engine you don't believe has any issues?
No, there's issues everything. You always, if you have reducing agent and oxidizing agent, there's always an issue. But there's really no other way to store energy with a high energy density. There'll always be danger no matter what you do. And at least this technology is not as explosive as gasoline in the cars.
Let's take another question. Go ahead, Mark.
What's the cost per kilowatt hour?
Good question. It's extremely inexpensive. There's no rare or noble elements involved in this technology at all. I didn't calculate the numbers, but I don't think it's going to be more than twice expensive than gasoline.
Final question, Nikhil?
Question from the audience, have you got one? What is the chemistry?
Read my patent applications.
There you have it.
Okay, so let's move into the feedback part. Nikhil, if you'd like to start.
Sure. So my feedback is fairly simple in regards to storage technologies that the proof is really in the pudding in terms of having prototypes and demonstration demonstration scale equipment that you can prove out that level of efficacy, start to get some numbers that help you calculate a cost per kilowatt hour. I mean, those are going to become the metrics that are critical in order to raise the kind of funding that it would require to take something like this to commercialization. So that would be my encouragement.
Feedback, Mark?
Yeah, really, I just would echo Nikhil. I would need to know, I'd want to be able to compare it to other available technologies, startup and existing, to know, assuming it worked, what kind of traction you get in the market.
Yeah, I think the having a prototype that actually is functional, because to me it's still not clear whether it's a battery or an engine or both, because you're referring to a fuel cell that has sort of its fuel included. If indeed it's sort of a combined package, I think the first market is a fleet operator, something like that, that's willing to prototype something fast and doesn't need a whole lot of infrastructure and can run a few vehicles or test the concept at a larger scale rather than go for a bigger market right away.
So you're not competing against internal combustion engines and gasoline. We're either going to switch from those to alternative fuels or we're not. If we're not going to switch from those, then game over. If we are going to switch, then you're competing against other alternate technologies, other battery technologies, other fuel cell technologies. And so the important question is not to compare yourself to internal combustion, but as Mark referenced, there are a lot of startups that are working on high energy density batteries that talk about 4x, 8x energy density of lithium ion, a lot of fuel cell solutions. So it's very important to understand what the metrics are of your solution are versus the other alternate solutions that are upcoming, and to be able to have that comparison and know what your value proposition is compared to those.
Great feedback. Let's have a round of applause for Yuriy. Take that mic. Okay, so we're not going to do any pitches right now. What we're going to do is take a few minutes of a break, and before we do that, we're going to go through a sponsor slide. So just have a word from our lovely sponsors here. Just a moment. And make sure you're voting on Twitter, so don't forget to vote.
Right. To vote for Yuriy, it is pound Future Energy and at Ftorion. Ftorion, Ftorion. And don't forget to vote for your panelists for their insightful advice. Here's one of our sponsors, Willem with GameChanger.
Yeah, just a brief word again of what we do. We are sort of the angel investor for Shell. So we'd like to incubate early stage startup technologies, both for universities or ideas. If it's just in an idea state, it could be still good enough for us, depending on how good the idea is and how good the people are and excited about it executing. So we run an ideas portal at www.shell.com/GameChanger, where anyone can submit an idea and then you'll get contacted whether there's any interest. And we have a very easy, flexible process to work with people on a lot of very different terms, depending on what would be the best partnership for both of us. So just want to get your attention to our website again, or just contact me or Richard Smith. He's with Shell. He's in the room as well. Richard, if you can raise your hand. So if you've got any questions about our GameChanger program or anything else we do in future energy space, just get a hold of us.
There's postcards outside the door, and I think both Richard and Willem are going to be at Mead Hall later this evening, so you can hit them up with all your creative energy ideas there.
Okay, so the next, I'm just going to ask John Rohde if he can come forward and tell us a little bit about Mintz Levin.
And my name is John Rudy, and I'm from Mintz Levin. We are a sponsor of this event, and just a very few quick words. We're obviously a full-service firm based in Boston, but with presence across the country in New York and Washington and California. And we're especially excited about this evening because we have a very strong leading clean tech, clean energy practice, and have been in the space for quite some time now and growing with the space. And so would encourage anyone here who has any questions or wants to talk about legal issues to, I'll be around to discuss or to contact us. I have brochures from our clean energy group, which I'll place up here if anyone's interested in picking those up to learn more about our practice and our clients and past transactions that we've advised on. And again, we are a firm that works with companies throughout their life cycle, starting from the very earliest stages all the way through exits and public offerings and larger transactions. So again, we would encourage anyone at any stage of development to come and speak with us, and we would look forward to working with them. Thank you.
Great, thank you, John. All right, and so now I'm just going to ask Dave Ulrich, if you can come up and just tell us a few words about Work Bar Boston, official space sponsor.
Thank you. Hey, it's kind of interesting to come here and see the different crowd that usually comes. Who has been to previous ULS events here? Just kind of curious. So, okay, so you probably heard me come up here and give the pitch about Work Bar Boston, but it's kind of good to give it to people who haven't heard of it. What it is a co-working space. Anybody familiar with co-working? Yes. Okay, so it's a shared office, shared resource space. So instead of working at the cafe, working out of your home, working out of your overcrowded office, you come work with us. And we like to think we offer more than just a desk and printers and fax machines and such. We offer a pretty good community. And as people were up here giving their pitches, it just kind of made me think that typically we get a very diverse crowd, but they're not in this industry. But I think it would act as a really good resource for a lot of people to come in and get involved, because it is a really diverse community with people from lawyers, designers, software people. So check us out. It's called Work Bar Boston. We've got a place we're at 711 Atlantic Ave. We're also, which is right across from South Station. We're also expanding into Cambridge, as well as we have a couple other programs that might be interesting to you. So if you're working out of your house, you're startup minded, come check us out, not just for the space, but for the community. Thanks.
Thank you, David. Okay. And obviously, as we mentioned, Amazon Web Services sponsoring the prize, as well as Microsoft co-hosting us here this evening. Graham, if you could hit the next slide, and we'll just tell about our service providers through Brightmap. So if you've received an introduction service this evening as you registered, you might have indicated that you'd like to receive an introduction to some of Ultralight Startup's preferred service providers. So that intro is provided through Brightmap service and that's available. You can see the logo here on the bottom. It's brightmap.com if you're interested in getting involved. But as we mentioned, the legal service provider here is Chris Lullier. Joe Chin providing SourcePad, web UI and design and development. As we mentioned, Dave Ulrich from Startup Office Space, and Nathan Therian from BISMA, which is Commercial Business Insurance. Nathan, are you here in the audience? Just wanted to point you out. So if you'd like to connect with Nathan, please do so after this. Okay, and announcements, do you want to?
Sure. So the next Investor Feedback Forum, which is not an energy-related event, but the same format as this, for internet startup companies and web-based companies, is going to be right here on June 21st. The next one in New York is going to be on June 13th. That's going to be in Javits Center. For those of you who are from New York or familiar with it, it's a big conference center there. And Geeks on the Train. Do we have a slide for that? We do have a slide for that. So this is an interesting project that I heard about recently. So there's going to be a set of internet startup entrepreneurs that are going to get on an Amtrak train in DC, and they're going to travel then up to Baltimore and pick up some more entrepreneurs, and they're going to travel from there to Philadelphia and then to New York, where they're going to have lunch and meet other New York-based internet entrepreneurs, get back on a train, and then come finally up to Boston, where they're going to go to Cambridge Innovation Center, and they're very explicit that the dinner they're going to have there is ribs. So maybe that's a big deal in Cambridge Innovation Center. I don't know. But if you want to be part of that, you guys can skip the whole train part of it, I guess, and just go straight over to Cambridge Innovation Center. So that's on May 24th, which is like next week, right? Awesome. So we'll take a 5-minute break. Try not to go too far because we really want to get back in here and wrap things up. Awesome. Thanks so much.
Thank you. Okay, we're ready to pick up the final pitch series here. So we've got Carl Persson here from Creek Power. So Carl, you've got 3 minutes. The floor is yours.
Thank you very much. Creek Power is a utility-scale renewable electricity provider. Currently, we are in the research stage. Our objectives are, number one, to be the low-cost producer of renewable energy when we exclude all incentives. Secondly, to qualify for baseload reliability, that's 75% load. We use a process based on the combination of seawater and fresh water. Usually you think of this in being an estuary. This process occurs naturally, but no energy is harvested, which means 2 terawatts of energy are lost to the atmosphere. Within the realm of marine-based renewable energy, the most intensive part is what we're dealing with. It has been used in the past. There is a capacitor-based process, so that is what we're using. It is not very efficient at this stage, and what we plan to do is to upgrade the technology in the electrochemical cell using state-of-the-art materials, taking advantage of advances in material science. Could I have the next slide, please? Within the electrochemical cell, seawater and fresh water are processed sequentially. In other words, we're not mixing these, and this is done to enhance the diffusion from the bulk fluid into the electrode. And this is rather smart. Wasn't developed by me, but still, we don't get the efficiency that we require. The seawater is sourced in the ocean or in estuary. Freshwater typically is coming from a river prior to it entering the estuary. Besides renewable energy, we have applications for water purification in fuel cells. We are currently working also in water purification. Each cell is comprised of 2 electrodes, the electrolyte, spacers, and current cells. Ions accumulate adjacent to the porous electrodes. I said adjacent because they don't react with the electrodes themselves. This prolongs their life to hundreds of thousands of cycles, whereas a battery reacts directly. Number of cycles is considerably less, and then they need to be replaced. The process typically runs through a cycle, typically 0 or a half a volt to a volt. Then the energy is harvested just by running a switch, running it through resistance to generate electricity.
10 seconds.
Process is insensitive to temperature. We are trying to establish proof of concept evidence for our solutions. The time frame of the work should be months and not be particularly expensive.
And it's time.
Good job. Round of applause. That was a good. All right, so let's move into the question section. So who would like to jump in and ask a question of Creek Power?
So can you clarify whether you can recycle the water, or after you mix it, it's spent as a brackish water?
A base case is...
Speak into the microphone, please. Microphone, please.
A base case is the water is spent. The seawater feed is intended to be spent and not recycled. The fresh water, which is limiting the process in terms of its capacity, we believe can be recycled productively and should be, but it needs to be tested.
So I'll give you the opportunity to finish your presentation. So the last thing you said was that you're trying to establish a proof of concept and it shouldn't be too expensive. What does that mean? How much, do you have any idea of how much it would cost to establish the proof of concept?
Of course. I'm going to give you a range.
Okay.
There's a base case of about 50,000. Normal case is 100,000. The 100,000 is, if we have problems, it enables us time to make changes to debug it. If we don't have any problems, then we want to run additional tests to establish design criteria.
And the proof of concept will have what level of efficiency?
I can tell you what the goal is. I wish I knew what it was going to be. The goal generally in the industry by researchers, and we are done financially modeling to support this, is 75%. That's thermodynamic efficiency.
Can you talk about where you would site these generation facilities and what sorts of challenges, if any, might be associated with that?
Siting is a function of capacity. We would expect to be scaling up over time. That is an underlying theme. Starting small, which could be local, and then we've identified many, many different rivers that fit that bill. The goal in a process like this is to scale up rapidly and to have capacities of 100 megawatts or more. To do that is probably, we are best off licensing technology or establishing relationships with a much larger partner. Now, some of the challenges you mentioned. Government is actually pretty friendly. Regulations are pretty friendly. What you get in opposition are local groups. Nice idea, but we don't want it here. And the solution to that, a couple of solutions. One is to move to less dense, less premier areas where there is not objection and there's plenty of capacity in those locations, or to establish installations where there's a real need, a pain threshold. If we have time, I'll give you examples.
Do you want an example, or should we call it there?
Example would be great.
One example.
I'll give you two examples.
Okay.
One area that's crying for renewable energy, and of course they'd like it to be cheap, is Nova Scotia. Nova Scotia has 10 major rivers, and they're average, and they're fairly close, by our work, 100 megawatts apiece, 100 gigawatts right there. Second example is Hawaii, most expensive electric rates in the United States. On one of the islands, there is an existing hydro facility, and I've forgotten its capacity, but if you go downstream from it, that fresh water can be reused in our process because there's plenty of ocean there, plenty of seawater, and that had, alone, one river had the capacity of a gigawatt. And if you allow me a third, if we go to Brazil, we have unbelievable capacity.
Brazil will be the third. Thank you. So should we go to feedback?
Let's move into the feedback. So what takeaway message would you like to give to Carl? Maybe David, we could start.
So you started off saying that you're in the research stage, which is a very fair statement and appreciated, because that's, it sounds very much like that's where you are, and that's where you should be at this point. So I think going forward, you want to get that proof of concept, and the amount of money you're talking about, I mean, hopefully that's, frankly, friends, family, and fools level of financing where you can establish a demonstration or a proof of concept. And in parallel to that, as we've talked about with some of the other presentations today, is then, work on the value proposition. As you're refining the proof of concept and seeing what the efficiencies is and what the costs are, then in parallel to that, develop what the market is and the customer segment, and look at those areas where there's the real pain, and come up with a plan on how you're going to sell to them.
Feedback, Willem?
Yeah, to me, once you start talking about 100 megawatt full scale in estuaries, I think that almost sounds like an infrastructure project. And then going from the current research where you are is really develop the technology staircase to get there without needing sort of a very expanded financing cycle. And how are you going to finance, a large scale project like this? And when you talk about 10 rivers at a high level, then by the time you've done all your due diligence and regulatory things, you might be down to only a few. So just focusing on the 100 megawatt might be very risky if you can't find another commercial embodiment that serves a smaller market and is more broadly applicable, and in areas where you can be creative on maybe energy storage or plug into renewable space somewhere else as well.
Mark?
Yeah, in the presentation, I was curious about the source of the IP and where the research came from, and also I'd be interested to see what this looks like next to its nearest competitor, whether it be natural gas or coal-fired plant, and what it looks like from a both CapEx and OpEx point of view, relatively speaking.
And Nikhil?
My comment would be that I think it's an interesting technology with a lot of potential, but going through that R&D process towards commercialization, particularly given the scale of what you're talking about, can be a very lengthy, time-consuming process. I've seen a lot of other companies that are really companies and technology innovators that have stumbled along the way in terms of continuing to finance that development and scale up. So I would just encourage you, and you're probably doing it already, but to pursue as many forms of non-dilutive financing, grants, things like that as possible to continue the research without having to take a lot of outside capital.
Okay, thank you.
That's great, and that concludes the feedback session. So round of applause for Carl, Creek Power. I'll take that microphone from you, Carl. Thank you very much.
Thanks, Carl. So if you would like to vote for Creek Power as the best startup tonight, send a tweet with #FutureEnergy and @CreekPower. And don't forget to vote for your panelists. Any comments that you thought were particularly insightful, you can tweet about that. Next up, we have Larry Grumer of Energy Harvesters. And then on deck, Brian Hodder.
Good evening, and thank you. My name's Larry Grumer. Our company is Energy Harvesters. We have some cool technology and a cool business model that we express through our product, the walking charger. It's going to be a personal electronics mobile power source. It's going to allow you to charge your batteries, your smartphone batteries, from the walking you do every day. It'll take about 1 hour of walking to give you a full charge for your smartphone. Our technology approach relies on proven technologies, something that's called the shake flashlight. You shake it, it lights. It's known as a Faraday generator. We've taken the same concept that's in this technology and we've innovated it with advanced materials. Next chart. With advanced materials, innovative packaging so it can go into your footwear, and we've gone ahead and made prototypes proving the working components. The way it works is that every time you take a step, your pressure will activate chambers, fluid-filled chambers within the insole. Those chambers will push fluid against the magnetic piston, and in turn, as you push your heel, it goes the other way. So it's a constant generating capacity. Competitively, there are no competing products on the market. They all suffer from either lack of power output, they're not reliable, they're all experimental. We have some significant advantage in a few areas. One, it's footwear integrated. Second, it is the only one that's out there that can bring a charge within an hour. Third, our OEM customers, the brand footwear, we bring innovation to them, we expand their market potential. And then lastly, we have positioning know-how within the industry. We've got an accomplished team. We have a senior executive who has worked for the footwear industry in sales and sourcing capacity. Our found-up partners are both P&L startup people, and our two people who will be joining our team who have built their own brands of footwear and have sold it. We met with many of the top 10 footwear brands, Adidas, New Balance, Vibram, Reebok. We validated the market need, and we confirmed explicitly the strong interest in what we're doing. Our objective is to raise $500,000 to build working prototypes to go back to those brands and engage O&M contracts with them and development partnerships with them. We look to spend about $300,000 on device development with that money and about $200,000 for market execution and additional patenting. It's a big market. It's a $40 billion market. We're addressing the work boot market, which is 2% of that. And within that work boot market, we see revenues accelerating through 50 million pair of shoes, which is our addressable market, from $5 to $15 million in years 3 through 5. And that really is an addressable market of less than 7%. Thank you.
Larry, I had to check to see if you were wearing a pair, so I was disappointed to see you were.
I do have something that's close, but that would have been a little too...
In any case. So let's start with some questions. Questions from the panel. Any order. Please jump in.
Larry, your presentation really focuses on the consumer market and opportunity. Your materials also reference the military market, but from your comments, it seems like that's not the primary focus of yours. I mean, I'd be curious what that value proposition is on the consumer side and how you came to that as being your primary focus as opposed to some of these other sectors.
So the work boot market includes work boot, military, consumer, recreation. The brands produce for both of those. The innovation we bring is to the brand. They wind up producing and bringing to market our OEM sold product embedded within their footwear. So they're the take-to-market people. The advantage to a military individual is carrying 40 pounds of batteries that they don't need to carry anymore because now they can recharge self. For the individuals, right now it's a convenience to be able to charge as you're walking around and not need to plug into the grid. For recreational, outdoor enthusiasts, military, police, people like that.
So does that, the innovations you have in the concentrator, can these be applied for regenerative braking as well? So completely different application?
Yes, it is, and good luck to them.
And so is there any need for intermediate energy storage? Like if you, after an hour and sort of, when do you have to plug in your cell phone?
Yes, that will depend on your usage, but the charging medium is an ultracapacitor. That's our charge storage device. That will actually be on the footwear, and that will be a universal charging port so that you take that off, plug it into your iPhone or my smartphone or other related devices. So it stands as a constant source, and then it goes back into the footwear for next recharge.
So 2 questions. First of all, have you walked a mile in these shoes? And what I'm getting at is 2 things: is have you demonstrated this, and what is the actual experience of walking in them? Do you feel a difference when you're walking on this as opposed to conventional shoes?
So we've built the components to prove out workability of the generator portion as well as the hydraulic portion. What we need is money to integrate that into a footwear, taking a linear generator, that shake flashlight, making it curved, which is no magic, but now having the tooling and the necessary integration for a footwear action. Because it's fluid-filled and because it's cushions, it should wind up having additional comfort. Plus, because you're moving a magnet in resistance, the harder you step, the more resistance the magnet coil gives you. So it actually should cushion you from jumping and related kinds of walking.
And how much is it going to cost? What will be the added cost to...
The selling price is $30 to $60 that we will sell to the OEMs. That's about at a 70% margin. And when we branch off to the next 200 million customers, which is the rubber-soled things, that's about an $8 to $18 selling price.
Okay, so we'll stop there for questions, and we'll move into the feedback session. So maybe Nikhil, if you'd like to start. Sorry, Mark. So you had the mic.
Sure. I'd say that, there's, over the years, been a number of different technologies focused around energy harvesting, and your description references that, so obviously you're aware. What I'd say is that it would be very helpful, I think, to investors, to the marketplace in general, to talk about why your technology is different. Where it succeeds, where others fail, and why this has a greater potential than those other approaches we've seen today.
Yes, sir. Thank you.
And Mark.
We didn't obviously get into a lot about the technology. One suggestion I would have is talking to MC10 about the stretchable electronics, because one question I had about was the reliability and the cycle life, given the rather difficult environment you're putting this electronics into. So you might already have that figured out, but check them out, because they might be an interesting...
And the name MC10?
MC10, MC10inc.com.
Willem?
Yeah, I think the prototyping seems to me very important early on. Can it be lightweight enough and sort of not interrupting? And then I think you have to think about how you can keep it fresh and not to be a gimmick that sort of gets launched once and then doesn't help. But I have to say, my kids have these shoes with these lights in it, and it's very frustrating that these lights, once they're out. You can't replace the batteries. So the kid shoes actually might be on a very small scale a good market as well.
There you go. So you mentioned that a member of your team has a background in the footwear industry. So I think the advice I would give here is, strategic alliances would be key. And so having strategic alliance or a strategic investment from a footwear manufacturer from that industry would give you a tremendous boost, and or looking for government grants or relationships through the military.
Excellent. Thank you. And we are.
Great advice. All right, round of applause. Good job.
Okay, so to vote for Larry and Energy Harvesters, send a tweet with #FutureEnergy and @eHarvesters. Also, don't forget to vote for your favorite panelists. There's so many insightful comments. It's going to be hard to choose, but that's your challenge. Next, we have Brian Hodder of Adventergy.
You have 3 minutes, Brian.
My name is Brian Hodder with Adventergy. The company was started to commercialize grid-scale storage, energy storage.
A pair of boots, watch.
It's a little.
Sorry.
Our project is a little bit bigger footprint than what you just saw. It's a variant on what's called pumped stored hydro, and what we do is we use large hollow structures on the sea floor. They serve as an anchor for a floating wind turbine. And the way they store energy is that you use excess energy from the wind turbine to pump out the structure. And then when you want to release the energy later, like when the winds die down and you still want to turn on your lights, you allow the water to run in under ocean pressure, and it's going through a turbine and is generating electricity, essentially hydroelectric energy. Next slide, please. So there are a lot of competitive advantages to what we're proposing. A lot of the new technologies for storage are unproven. One of the advantages we have is it's proven. Pumped stored hydro has been around for 120 years. It's the most widely used method of bulk storage in the world. And large concrete structures in harsh marine environments have been around for 40 plus years. Think of the North Sea oil exploration fields. Solves two critical problems that are commonly associated. One critical problem that's commonly associated with wind in general, which is intermittency. So we can store energy and release it on demand. It's dispatchable power instead of being stuck, only being able to run the lights when the wind is blowing. And the second issue is there are more and more countries, there are at least a dozen consortiums worldwide that are looking at floating wind. The idea is to put the wind platforms farther offshore. One, it's out of sight, so the NIMBYs, they can't see the NIMBYs from the turbines, so we don't have the same debacle that we had with Cape Wind, getting that approved. And it provides anchoring for the platform. One unit can store up to 20 megawatt hours of energy, which is significant. That's equivalent to, and we're dealing with intermittency here, so it's equivalent to roughly 2,000 average American homes for 8 hours. And at that level, it figures out to about 7 cents per kilowatt hour for stored energy. And right now, the best competitive price in alternate technologies is 10 to 12 cents. So we've got a nice price point. And advance, please. So there's really a huge opportunity. There was a 2010 study. 10-year domestic value of storage was estimated at $228 billion. That was Sandia National Laboratories for the U.S. government. Worldwide, as I mentioned, there are a number of consortiums looking at floating wind platforms. So the market is not just domestic, but that domestic market is huge. So we're also, at this point, we are applying for grants to help support the engineering at this point. It's not research, it's proven technology. It's the engineering to figure out exactly how to do it. So we're looking at grants, VC funding to help develop strategic partnerships. We've been talking to platform manufacturers, turbine manufacturers, heavy construction companies. We need to talk to wind farm developers. And we really want to educate investors and the utilities to pull this because it adds so much value.
And that's time.
All right, round of applause. Good job.
Thanks, Brian.
Okay, panel, who wants to ask a question?
So, a great presentation. Two clarifying questions. One is, do you know what the round-trip efficiency will be, i.e. how much of the energy that you're using to pump is going to be recovered?
What we're using in all our financial projections right now is 70%. But typical for pumped stored hydro, it's 70 to 85%. And experts I've talked to say it's 70 is very conservative. So we're just trying to stick with conservative estimates when we make our calculation.
And do you have any sense on how your system, the pumps, the transmission lines, and so forth, are going to do sitting underneath the ocean for an extended period of time, which is a very harsh environment?
Like I said, the North Sea platforms have been there for 40 years, and they're a lot bigger than ours are. As far as transmission, there are much longer cables than anything we would envision. They're 580-kilometer cables running from Netherlands to Norway. They use Norway like a battery. As far as the harsh environment, they've been doing pumping technology in the oil industry. We're going to be able to borrow a lot from the oil industry in that regard. And just one other comment I'd make is that Japan actually has, most pumped stored hydro is on land with 2 different reservoirs on land. Japan has one in Okinawa that uses the Philippine Sea as the low reservoir. So they have experience with the corrosion and the fouling that you're going to have in an ocean environment.
This is a feat of engineering more than a product or a service, as you suggested. And you mentioned a number of different constituents from the turbine manufacturers, the construction companies, the engineering, utilities. So who is the customer here? How do you actually sell this?
We're still refining that model. I mean, especially when you talk about anything that's this large scale, the customer, it's not a consumer product for sure. And that's why I said we want to work to reach out to investors and utilities to educate them on the value that our system can provide because of the storage, because it helps address the intermittency problem, the problem of integrating.
So the developers, I guess, the value accrues to them, I suppose.
Right. It's a more marketable product. They can sell at peak prices instead of, worried about curtailment issues.
So the 20 megawatt hour unit, how big of a box is that on the ocean floor?
It's a 30-meter sphere at 750 meters. And our current intention is to identify, the deeper it is, the better it is, the energy density, because the pressure is so much greater. So what we would be doing is targeting the deeper areas as we continue to refine the production, and then we'll use the economy of scale and drop the production, and then we can go for shallower areas.
So what do you pump in if the water goes out?
You pump water out, and when it's empty, that's when it's charged.
But it's with air.
And to release the energy, you allow water to go in, and it's jetting in under the pressure that you have from 750 meters of head.
Right, but as you pump the water out, you pump air in, I assume.
With this design, it shows what's called a tension leg platform. We can run a vent line up. These things would actually serve as rails for robots going down for any maintenance on the pump unit to remove it and replace it. And there'd also be a vent line, so you're not, if we can't do a vent line for particular circumstances, then we'd run a partial vacuum. So that does reduce the energy yield a little bit, but it still continues to obey the laws of physics. So.
Okay, that's time for questions.
All right, let's move into the feedback session now, so we can, Nikhil, we can start down the end since you didn't get a chance to.
Yeah, what I'd say is that in terms of feedback, if indeed you're talking about a lot of different technologies that have been proven out at scale in similar sorts of conditions, which it resonates with me, I'd say that this is very much an execution play, and a critical element of that then is having the right team around you. So not having dug into that in the Q&A piece, I'd simply say having those right team members on the engineering side, on the financing side, to think about how these sorts of systems will get project financed over time, people who can sell into those utility markets and developers speak. That's going to be critical to your success here over time.
And Mark?
I would include in your presentation what it does for the wind developers, how it changes the economics of a wind farm, and because that's really the payoff.
Yeah, I think the storage, I mean, it's obvious there's going to be a market for storage. The question is, how do you value that, and who's going to pay for that, and how much infrastructure can you afford for it? But I'd be hesitant to link myself too much to offshore wind, as offshore wind is still very expensive, and the improvement's going to be in the anchoring or how you actually get there. So unless you got a very good partnership, see where there's any viability in storage itself, and bring the cost down. Maybe you refer to offshore assets a lot, so maybe there's something you can retrofit or leverage as some of these assets get abandoned to get a first demonstration deployed at a much lower cost.
And David.
So a technical question I didn't get to ask, so consider this a comment. But I was wondering, if you're pumping air into these large storage containers underwater, is it creating any buoyancy and then reducing the effectiveness of the anchoring? And so, no, good. I presume, but the thought occurred. And the feedback that I had is, it is clear that wind farm developers are it seems to me at least that wind farm developers are your customers. So I would go out and get feedback from them as much as you can, as soon as you can, and really, once again, find out how you're going to address their needs, and try and make this an iterative cycle here. As you're developing your technology, have an ongoing conversation with them.
Great feedback. Round of applause. Good job.
Thank you so much, Brian. So to vote for Adventergy and Ocean Renewable Energy Storage, you'll send a tweet with #Future Energy and @Adventergy. Also, don't forget to vote for your panelists. So we have, I believe, Neil Livingston of Carbonaceous Synfuels has yet to arrive, unless he's here now. So we have a spot for a stand-in panelist. I believe this gentleman in the gray has volunteered. Yes. You want to come up? It's your lucky day.
John Merlino from Sirius Integrator. Very nice. John, is there a website that we should pull up? He's got slides.
Wow.
My
You came
goodness.
prepared, man. Okay. This is like extra credit for this.
Start voting now.
It's actually the result.
Okay. Wow.
Wow.
Don't scan. I'll take your word for it. There's no viruses on it.
Got 3 minutes.
Great. My name is John Merlino from Sirius Integrator. We have a Devon's office that focuses in on distributing and integrating direct methanol fuel cells from Germany for the last 3 years. We have a focus on taking that pure methanol that you see in the picture there, passing it across a platinum stack, and producing electric for small sub 100 watt applications. So we're powering off-grid devices like cameras and sensors and detectors and radar. There are so many devices that are off-grid that the further you get away from the grid, the more valuable our solutions are. And so right now it's squarely focused on increasing sales to the niche markets that we pursue for the direct methanol fuel cell. Very soon, or right now, we are starting the piloting of a 250 watt propane fuel cell. We'll have a 500 also to get to the 30% tax credit that's available to fuel cells over 500 watts. Next. So we have some very unique products we manufacture right in Randolph, Mass. with Newcom. We have a -50 enclosure, and from the last Mass Challenge, suggested that I acquire more IP. We licensed exclusively a -50 design for the PEM fuel cell to operate in -50. Shell and Tyco uses it right now, and I'd like to have them use it in a bigger way. And so very cold power is very much in need on the borders, the northern borders. We have EFOI Pro fuel cells under fake rocks on the southern border with the DEA right now for 1 year, and they're looking for funding for many more of them. Under cactus and fake rocks. So northern border, southern border, oil and gas infrastructure for infrastructure like chemical injection pumps, SCADA devices, communication systems. There are many air compressors in the oil and gas business. There's many devices that need power off grid. So we are maximizing the time that they could stay out in the field unattended. And that means reduction of the cost of operating those with less site visits. So you see in the picture, we're hybriding solar and micro wind turbines as range extenders only, because they're not reliable power sources in our mind. The fuel cell is the reliable power. The others are just reducing the fuel use and increasing the time between site visits.
15 seconds.
Yep. If you throw the other one up, it just shows that we have several customers, about 35 major customers, all of which I'd like them to move from 1 and 2 units per order to 5 and 10. We have some 5 and 10 unit orders, but we're getting very big opportunities in the seismic space as well as the security space and wind application space.
And that's
Thank
time.
Good job, John. hang on to the
We'll
mic
need that
a
for
second.
Q&A.
Yeah, so we're going to do a quick round of Q&A. So David, looks like you're reaching for it, so jump in with a question.
So what is the cost per kilowatt of capacity? What's the lifetime of the units? And what are the maintenance costs and intervals?
I'm going to shock you. For the solutions we provide today, it is 46 cents in the continental U.S. per watt hour, not kilowatt hour. And in Alaska and Hawaii, it's 62 cents. When we bring on the propane 250, it's going to go down to 10 cents. So adoption's going to really, I think, start in the next year. I'd say early 2013.
So that's for your energy production, but what's the cost per kilowatt of capacity?
Kilowatt of capacity, I'd say the systems run from 4 to 10,000. They're producing from half a kilowatt to 2.2 kilowatts with the direct methanol fuel cell. So I would say a couple of $1,000 a kilowatt per day. It's a per day figure. Yeah.
Question, Willem?
What's the key differentiated technology of the fuel cell itself?
Just longer autonomy. Just longer run times that are really dramatically larger than any battery system. We're gonna, with the propane system, we'll stop powering lithium packs, phosphate packs. But up to this point, it's been only lead-acid battery, small configurations, lessening the battery pack size, to 1 or 2 12-volt or 24-volt systems. And the hybriding and using integration know-how is one of the things we're adding. Now, the big opportunity is in the smart off-grid portal that would wrap all of these fuel cells and batteries up in a.
Is there any adaptation possible for micro CHP, for like home applications?
Well, I'm looking into the new propane fuel cell throws 550 watts of heat, which is 80 C of heat. And so I'd like to produce a TEG that takes that ventilation, that hot air, and takes back 20 to 40 watts off of the heat. That's going to be a value add that we're working on as an enclosure manufacturer.
Other questions from the panel?
So, John, this is an established German company? Is this
my company is a U.S. company. 3 years ago, we went to Germany, and they have 24,000 fuel cells worldwide sold already to commercial markets.
Okay, the ones that you're selling?
Yes, and
okay.
we've been selling them in the U.S.
So you have the U.S. market
Yes,
for this?
and moving into Canada.
Okay.
Yes.
And so you've already got a number of customers, it sounds like. You're out there, you're field
over
deployed.
35,
There's no technology risk here.
That's right.
You're doing it. So what's it going to take, do you think, for you to, what's the inflection point? What's going to have to happen for you to sort of blow this out to a big business?
Two things. A platinum-less stack, so the propane fuel cell, once we scale, will be less expensive and will go down in price quite quickly, I believe. After 1,000 units, after 500 units, we'll see a price go down. And also regular fuels used so that you don't have to ship. We've been shipping to Alaska through the barge and everywhere in the U.S. with certified hazmat shipping methanol. And we've got to get rid of that. We don't want to be in the fuel business. We want to just have people use propane or diesel. So in a couple of years, the diesel fuel cells will come to the market. And I've been in communication with CEOs of every fuel cell company globally, talking to them about when their fuel cells are timeline to come out.
It's time.
Yeah.
Great, so that wraps up the question part of it. So now we're going to move into the feedback forum. Nikhil, would you like to start with giving feedback to John?
Yeah, I saw John pitch earlier today, so not fair. But, what I would say, John, is there's a few capabilities of your technology in terms of that longer autonomous operating period, the cold temperatures that it can operate in. I would really look, as part of this presentation, look to include analysis of which subsegments really benefit from that and what that economic value is and how that can translate into business opportunity for the company.
Feedback, Mark?
I'm not sure how valuable this is because I'm sure you've already thought of it, but I'm told by the cell tower guys all the time that they're really looking for a better solution. So, There you go.
I think in line with that, I think it's finding the right markets where your fuel, where you can supply the fuel, and where it can really monetize the benefits. And I think if you're going to intermittency, I think there's quite a few people looking at renewable methanol. So if you really want to go to renewable integration and you can link it with any renewable methanol, you might have sort of an alternative or a more interesting proposition there as well.
So you have an established technology, you have established customers, so you're pretty far along. So I would want to know, what your use of funds is. If you're looking for investments or grants, how are you going to use those funds to accomplish your goals, to scale what you're doing?
And that wraps up the feedback forum. So round of applause, great job. Great improvisation by John Merlino.
Yes, so if you'd like to vote for John, let's say pound Future Energy at Sirius, Sirius. Yeah, right here. Okay, so now is a good time to vote if you have not already done that.
So this brings us to the pitch showdown, which maybe you saw as an announcement of the event design. So now is the final point. We're going to take a minute for you to get all of the tweets in that you'd want to vote on. So if you'd want to vote on any companies in reflection or any comments from your panel, get them in now, and we're tallying up the Twitter accounts right now. So submit your final tweets, and we'll announce the winners in just a second.
In the meantime, do we have more announcements?
We do. We have
Drinks at Mead Hall. Should we review the prizes?
That sounds like a great idea.
Okay, so while you're all viewing, so you're deciding who's going to win these prizes, which startups, and which panelist is going to win really the greatest prize of all, which is the Audience Choice Award. As you're doing that, Chris, what are the prizes again?
Yeah, so if you could pull up that slide, Grim. So basically, top winner is going to win tonight. The Cleantech opens Northeast application, and a fast track application to this program, and top winner also will win $1,000 worth of legal services from Mintz Levin, and then the top 3 winners will all receive $500 worth of services from Amazon Web Services, and then all of the pitchers will win a week pass to Work Bar Boston.
Awesome.
So,
I have the answers right here.
Awesome.
Okay, so when we announce your name, come on up. Thank you, first of all, to all the presenters. Fantastic job tonight. Round of applause to everybody. In third place, we have Deckard Sorensen of NBD Nanotechnologies. Congratulations, Deckard. Come on up. In second place, we have Larry Grumer of Energy Harvesters. And in first place, most votes, your choice for the best pitch tonight, Ben Polito of Pika Energy.
Congratulations. So we don't have a big bottle of champagne to spray over you.
So we will be contacting you about your prizes momentarily. Panelists awards. So first we want to thank David Miller from Clean Energy Venture Group, William Rensink from Shell International, Nikhil Garg, Black Coral Capital, and Mark Goodman from Terawatt Ventures. Thank you very much. Your choice for the Panelist Choice Award, David Miller, Clean Energy Venture Group. Congratulations to everyone. And we will see you all momentarily at Mead Hall, which is just a few blocks away from here. So thank you very much. Thanks, Chris.
That concludes our event. So hopefully we can see you down at the Mead Hall for after drinks and networking. Thank you very much. Good night.